everyone, nice to meet you here on this platform. Yeah, this is the platform, actually a learning platform. On this platform, I am going to elaborate many subjects in detail. So, support my journey because behind it has a lot things. I mean, my hard works and my time. I wish and confident that you love these videos, my efforts. So do like and share this episode as well. Subscribe this channel. As I am from civil engineering field, so I am going to elaborate here about civil engineering subjects at beginning. Among the many subjects of civil engineering, first I have choose to explain building materials. So in this subject, you are going to know about principal properties of building materials. Yeah, this is the episode number 1 of building materials. That is principal properties of building materials. Let's start without wasting much time. Building materials. As we know, the construction materials play a very important role in this modern era. Although the most important use of building material is in construction activities. No field of engineering can be imagined without their use. Also, the industry, I mean the building materials industry, is a very important contributor to our national economy as its production controls both the rate and quality of construction work. Yeah, there are some general factors that affect the choice of materials for a particular project while we are going to choose. Perhaps the most important factor in this is the weather background. Obviously, climate change has led to the development of different materials and different construction is the economic aspect of material selection. Due to the great variety of uses of buildings and installations and various production processes, building materials require a wide range of their properties. Specific properties of building materials serve as a basis for dividing them into separate groups. The main properties of construction materials predetermine their applications. Only a comprehensive knowledge of material properties allows rational selection of materials for specific service conditions. In order to develop products of greater economic efficiency, it is important to compare the performance of similar materials under specific service conditions. Additional cost can be reduced by improving the quality of construction materials and products. So economists in the construction industry must have a good working knowledge first of building materials, second of their optimal applications based on their main properties, and third of their production techniques so that buildings and installations can have optimal engineering. Economic performance and efficiency. After acquiring sufficient knowledge, an economist specializing in the field of construction becomes an active participant in the development of the construction industry and the production of construction materials. As we saw why we need to know about the main properties of construction materials, let's see one by one. So, here I have categorized many properties as physical properties, mechanical properties, chemical properties, electrical properties, magnetic properties, and thermal properties. Let's discuss about physical properties of building materials one by one. Density. You all heard this many times. Simply, it's the ratio of mass of the material to its volume in homogeneous state. Here, homogeneous means the material exclude pores and voids. Almost all the physical properties of materials are influenced by its density value. It is denoted by rho and measured in gram per cubic centimeters, where mass in grams while volume is in cubic centimeters. Now remember some basic densities of important building materials as follows. Wood have its density about 1.5 to 1.6 gram per cubic centimeters. Brick have its density about 2.5 to 2.8 gram per cubic centimeters. Granite have its density about 2.6 to 2.9 gram per cubic centimeters. Portland cement have its density about 2.9 to 3.1 gram per cubic centimeters, and steel has its density about 7.8 to 7.9 gram per cubic centimeters. Next is the bulk density. Yeah, it's to have simple definition. It's the ratio of mass to the volume of the material in its natural state, that is including voids and pores. Here, natural materials include pores and voids. Bulk density influences the mechanical properties of materials like strength, heat, and conductivity. It is denoted by rho subscript small b and measured in kilogram per cubic meters, where mass in kilograms while volume in cubic meters. For most materials, bulk density is less than density, but for liquids and materials like glass and dense stone materials, these parameters, density and bulk density, are practically same. Properties like strength and heat conductivity are greatly affected by their bulk densities. Here also remember some basic bulk densities of important building materials. Pine wood have its bulk density about 500 to 600 kg per cubic meters. Brick have its bulk density about 1600 to 1800 kg per cubic meters. Sand have its bulk density about 1450 to 1650 kg per cubic meters. Granite have its bulk density about 2500 to 2700 kg per cubic meters, and steel has its bulk density about 7850 kg per cubic meters. Next is the density index. Density index is the ratio of bulk density and density. It is denoted by rho subscript 0. It indicates the degree to which the volume of a material is filled with solid matter. For almost all building materials, density index is less than 1 because there are no absolutely dense bodies available in nature. Next is the specific weight. It is the ratio of weight per unit volume of material. It is denoted by gamma. It is also known as unit weight. To know the specific weight of material by multiplying density of the material with gravity. The specific weight of water on earth is 9.80 kN per meter cube at 4 degrees Celsius. These properties can be used in civil engineering to determine the weight of a structure which is designed to carry a specific load. Next is the specific gravity. It is the ratio of weight or mass of a given volume of solid to the weight or mass of an equal volume of water at 4 degrees Celsius. It is denoted by G suffix S. It is calculated by dividing weight or mass of water to the weight or mass of solid. At 4 degrees Celsius, specific gravity is equal to 1 gram per centimeter cube or 9.8 kilonewton per meter cube. Next is a true or absolute specific gravity. If both the permeable and impermeable voids are excluded to determine the true volume of solid, the specific gravity is called true or absolute specific gravity. Next one is apparent specific gravity. If both the permeable and impermeable voids are included to determine the true volume of solids, the specific gravity is called apparent specific gravity. It is the ratio of mass density of fine-grained material to the mass density of water. Next is the porosity. It is the degree to which volume of the material is interspersed with pores. It is expressed as a ratio of the volume of pores to that of the specimen. Porosity is indicative of other major properties of material such as bulk density, heat conductivity, durability. Dense materials which have low porosity are used for constructions requiring high mechanical strength. On the other hand, walls of buildings are commonly built of materials featuring considerable porosity. Next is the void ratio. It is the ratio of volume of voids to the volume of solid. If an aggregate is poured into a container of any sort, it will be observed that not all of the space within the container is filled. To the vacant space between the particles of aggregate, the name voids is applied. Necessarily, the percentage of voids like the specific weight is affected by the compactness of the aggregate and the amount of moisture which it contains. Generally, void determinations are made on material measured loose. There are two classes of methods commonly employed for measuring voids, that is, direct and indirect methods. The most used direct methods consist in determining the volume of liquids, generally water, which is required to fill the voids in given quantity of material. Since in pouring water into fine aggregate, it is impossible to expel all the air between the particles, the measured voids are smaller than the actual. It therefore becomes evident that the above direct methods should not be used with the fine aggregate unless the test is conducted in a vacuum. Remember this point that direct methods should not be used with fine aggregate unless the test is conducted in vacuum. By the indirect method, the solid volume of known quantity of aggregate is obtained by pouring the materials into a calibrated tank, partially filled with water. The difference between the apparent volume of materials and the volume of water displaced equals the voids. If very accurate results are desired, void measurement should be corrected for the porosity of the aggregate and moisture it contains. Next is the hygroscopicity. It is the property of a material to absorb water vapor from air. It is influenced by air temperature and relative humidity, types of pores, number and size of pores, and by the nature of substance involved. Next is the water absorption. It is the ability of material to absorb and retain water. It is expressed as percentage in weight or volume of dry material. Water absorption by volume is always less than 100%, whereas by weight of porous material it may exceed 100%. The properties of building materials are greatly influenced when it is saturated. The ratio of composite strength of saturated material with water to that in dry state is known as coefficient of softening, and coefficient of softening describes the water resistance of material. Coefficient of softening describes the water resistance of material. Coefficient of softening is 0 for the materials like clay which soak readily, whereas for materials like glass and metals, coefficient of softening is 1. Materials with having coefficient of softening less than 0.8, that materials should not be recommended where the material is permanently exposed to the action of moisture. Next is the weathering resistance. It is the ability of material to endure alternate wet and dry conditions for a long time without considerable deformations and loss of mechanical strength. Next is the water permeability. It is the capacity of a material to allow water to penetrate under pressure. Materials like glass, steel, and bitumens are impervious. Next is frost resistance. It denotes the ability of water saturated materials to endure repeated freezing and thawing with considerable decrease of mechanical strength. Under such conditions, the water contained by the pores increase in volume even up to 9% on freezing. Thus, the walls of the pores experience considerable stresses and may even fail. Next is the heat conductivity. It is the ability of a material to conduct heat. It is influenced by nature of material, its structure, porosity, character of pores and mean temperature at which heat exchange takes place. Materials with large size pores have high heat conductivity because the air inside the pores enhances heat transfer. Moist materials have a higher heat conductivity than dried ones. This property is of major concern for materials used in the walls of heated buildings since it will affect dwelling houses. Next is the thermal capacity. It is the property of a material to absorb heat described by its specific heat. Thermal capacity is of concern in the calculation of thermal stability of walls of heated buildings and heating of materials, for example for concrete laying in winters. Next property is the fire resistance. It is the ability of a material to resist the action of high temperature without any appreciable deformation and substantial loss of strength. Fire resistant materials are those which char, smolder, and ignite with difficulty when subjected to fire or high temperature for long period but continue to burn or smolder only in the presence of flame. For example, wood impregnated with fireproofing chemicals. Non-combustible materials neither smolder nor char under the action of temperature. Some of the materials neither crack nor lose shape, such as clay bricks, whereas some other like steel suffer considerable deformation under the action of high temperature. Next property is refractoriness. It denotes the ability of a material to withstand prolonged action of high temperature without melting or losing its shape. Materials resisting prolonged temperature of 1580 degrees Celsius or more are known as refractory materials. High melting materials can withstand temperature from 1350 degrees Celsius to 1580 degrees Celsius, whereas low melting materials withstand temperature below 1350 degrees Celsius. Next property is durability. It is the ability of a material to resist the combined effect of atmospheric actions and other factors which is related to atmospheric actions. Next property is spalling resistance. It is the ability of material to undergo certain number of cycles of sharp temperature variations without failing is known as spalling resistance. It is the dependent of coefficient of linear expansion. Spalling resistance is the dependent of coefficient of linear expansion. Now we have last physical properties, and that is coefficient of softening. Coefficient of softening of material is the ratio of compressive strength of saturated material to its compressive strength in dry state. It affects the strength of water absorbent materials like soil. Now you are going to know mechanical properties. The importance of mechanical properties considered for building materials are strength, compression, tension, bending, impact, hardness, plasticity, elasticity, and abrasion resistance. Mechanical properties. The first property depends on the mechanical properties is the strength. The capacity of a material to resist failure caused by loads acting on it is defined as strength. The load may be compressive, tensile, or bending. It is determined by dividing the ultimate load taken by the materials with its cross-section area. Strength is an important property for any construction materials. So, to provide maximum safety in strength, factor of safety is provided for materials, and it is selected depending on nature of work, quality of materials, economic conditions, etc. Compressive strength is found from test on standard cylinders, prisms, and cubes. Compressive strength is smaller for homogeneous materials and larger for less homogeneous materials. For same cross-sectional area, prisms and cylinders have lower resistance than cubes. For same cross-sectional area, prisms and cylinders have lower resistance than cubes. On the other hand, prisms with heights smaller than their sides have greater strength than cubes. This is due to the fact that when a specimen is compressed by the platens of the compression testing machine within which the specimen is placed, it presses tightly the bases of the specimen, and the resultant friction forces prevents the expansion of the adjoining faces, while the central lateral parts of the specimen undergoes transversal expansion. The only force to counteract this expansion is the adhesive force between the particles of the materials. That is why a section away from the pressing plates fails early. The test specimen of metals for tensile strength are round bars or strips, and that of binding materials are of the shape of figure 8. Bending strength tests are performed on small bars, beams, supported at their ends and subject to one or two concentrated loads, which are gradually increased until failure takes place. Next property is the hardness. Hardness is the ability of a material to resist penetration or scratching by a harder body. Mohs scale is used to determine the hardness of materials. Hardness is most important to decide the uses of particular aggregate. It also influences the workability. Hardness of metals and plastic is found by indentation of steel ball. Next is the elasticity. The capacity of a material to regain its initial shape and size after removal of load is known as elasticity, and the material is called as elastic materials. Ideally, elastic materials obey Hooke's law, in which stress is directly proportional to strain, which gives modulus of elasticity as the ratio of unit stress to unit deformation. Higher the value of modulus of elasticity, lower will be the deformations. Within the limits of elasticity of solid bodies, the deformation is proportional to the stress. Next mechanical property is plasticity. Plasticity is the ability of a material to change its shape under a load without cracking and to retain this shape after the load is removed. Some of the examples of plastic materials are steel, copper and hot bitumen. Next is the brittleness. When the material is subjected to load, if it fails suddenly without causing or showing any deformation, then it is called brittle materials, and this property is called as brittleness. For example, concrete, cast iron are the brittle materials. Next property is fatigue. Fatigue. If a material is subjected to repeated loads, then the failure occurs at some point which is lower than the failure point caused by steady loads. This behavior is known as fatigue. Impact strength. If a material is subjected to sudden loads and it will undergo some deformation without causing rupture is known as its impact strength. This property defines the toughness of material. Impact strength property defines the toughness of material. Abrasion resistance. Next is the abrasion resistance. The loss of material due to rubbing of particles while working is called abrasion. The abrasion resistance for a material makes it durable and providing long life. Last mechanical property is the creep. Creep is the deformation caused by constant loads for long period or long times. It is time dependent and occurs at very slow rate. It is almost negligible in normal conditions, but at high temperature conditions, creep occurs rapidly. At high temperature condition, creep occurs rapidly. Our next property is based on chemical resistance. The properties of materials against the chemical actions or chemical combinations are termed as chemical properties, and they are chemical resistance and corrosion resistance. See chemical resistance. The ability of a construction materials to resist the effects by chemicals like acids, salts and alkalis is known as chemical resistance. Underground installations, constructions near sea, etc. should be built with great chemical resistance material. So next is a corrosion resistance based on chemical resistance. The formation of rust, that is iron oxide, in metals when they are subjected to atmosphere is called as corrosion. So the metals should be corrosive resistant. To increase the corrosion resistance, proper measures should be considered, otherwise it will damage the whole structure. Next property is the electrical properties of building materials. The properties of a material to conduct or to resist electricity through them are electrical properties of materials. For example, wood have great electric resistance and stainless steel is a good conductor of electricity. Next is the magnetic properties of building materials. The magnetic properties of materials like permeability, hysteresis, etc. are required in the case of generators. Iron is magnetic materials and aluminum is non-magnetic materials. Next is the thermal properties of building materials. It includes properties like thermal capacity, thermal conductivity, thermal resistivity and specific heat. Let's see thermal capacity. Thermal capacity is the property of a material to absorb heat and it is required to design proper ventilation. It influences the thermal stability of walls. It is expressed in joule per Newton degree Celsius and it is calculated by this formula, where H is the quantity of heat required to increase the temperature from T1 to T2. T1 denotes initial temperature while T2 denotes final temperature, and M is the mass of material in Newton. Next property is thermal conductivity. The amount of heat transferred through unit area of specimen with unit thickness in unit time is termed as thermal conductivity. It is measured in kelvins. It depends on material structures, porosity, density and moisture content. Thermal conductivity depends on material structures, porosity, density and moisture content. High porous materials, moist materials have more thermal conductivity. High porous materials as well moist materials have more thermal conductivity. It is the thermal resistivity. It is the ability to resist heat conduction, and it is reciprocal of thermal conductivity. When it is multiplied by thickness of material, it gives thermal resistance. Thermal resistivity of soil varies from 30 to 500 degree Celsius centimeter per watt. When it is multiplied by thickness of material, it gives thermal resistance. Thermal resistivity of soil varies from 30 to 500 degrees Celsius centimeter per watt. Specific heat. Next property. Specific heat is the quantity of heat required to heat 1 Newton of materials by 1 degree Celsius. Specific heat is useful when we use the material in high temperature area. Specific heat values of some engineering materials as below. For steel, it is 0.046 into 10 raised to the power 3. For wood, it is 0.239 to 0.270 into 10 raised to the power 3. And for stone, it is 0.075 to 0.09 into 10 raised to the power 3. The last part of this episode is the characteristics behavior under stress. Building materials under stress are ductility, brittleness, stiffness, flexibility, toughness, malleability, and hardness. Everyone must remember the points that I am going to tell you. Examiner makes many questions about these properties. Yeah, I have seen in many question papers. It's why I am telling you to remember these points. The ductile materials can be drawn out without necking down, the examples being copper and wrought iron. Brittle materials have little or no plasticity. They fail suddenly without warning. Cast iron, stone, brick, and concrete are comparatively brittle materials, having a considerable amount of plasticity. Stiff materials have a high modulus of elasticity, permitting small deformation for a given load. Flexible materials, on the other hand, have low modulus of elasticity and bend considerably without breakdown. Tough materials withstand heavy shocks. Toughness depends upon strength and flexibility. Malleable materials can be hammered into sheets without rupture. It depends upon ductility and softness of materials. Copper is the most malleable materials. Hard materials resist scratching and denting, for example cast iron, chrome, steel. Materials resistant to abrasion such as manganese are also known as hard materials. So hello everyone, this episode ends here. I am very grateful to those civil engineers who are watching my videos till the last moment. See you in the next episode. Till then, bye bye, take care. God bless you all.